Hello, good morning. This is another installment of a small series which I dubbed Technology Management for Managers. So it's not a technology management for technologists, but really for managers. For those managers, I may come across as being too technical, and for the technologists, I'm probably gonna be coming across as being, too general. Um, let's see how it goes. It's an experiment, as said. To briefly present myself and why I'm doing this, I'm a freelancer. I've always been oscillating a little bit during my 30 years of career between project management, finance, and technology, ICT management. Um, let's not waste too much time on introductions and the objective of this video. Um, I think I ended or I used this slide in a previous presentation. I think when you engage in the field of technology, ICT management, you always constantly need to be aware of, I think, two kinds of views that are there and that you need to have. One view is really a process view in a DevOps perspective, which has become a methodology that is quite common and popular right now. It would be the operations side of things. So a process view will look at how your ICT organization is dealing and executing, implementing or managing permanent functions or processes in your organization. Request fulfillment, incident management, problem management. These are not things that um, have sort of a very definite start and end point. No, they're permanent functions and processes in your organization. And I pointed out here out the model you will use there. The standard model is ITIL or ATIL, which has two aspects. Here I'm highlighting the service management model. They also have an asset management model, which is quite interesting. But basically, yes, service IT, service management. And then the nice thing about the ITIL model is that it gives you a standard model that incorporates best practices and standards, and also comes, if you want it, with a lot of benchmarks on how things should work, against which then you can benchmark how things are actually working in your organization. The thing with this process view is that you need to realize that people who think about that on how to improve these processes, um, they work with an entirely different tool set than what I show here on the right hand side. The developers, the project people, who something changes, they need to implement it. Code or configuration or data structure changes or environment. Then I'm really talking, technical environment, maybe test unit integration. Production environment that changes, new platform that you're going to use, and so you need to make that change happen through building or testing something, deploying it, and then sort of seeing if you're happy with it or not. And if you're not happy with it, you need to roll back, and otherwise, you start, you celebrate not too long, and you start with the next project. I think these two different views, I said, are supported by completely different tools, and that sort of also creates, sometimes I've seen that, two different mindsets, and it's not always easy to have people from one side talk to the other. The development team will maybe not be worried about processes such as the support, the help desk function that you need to organize around a new application, and vice versa. Operations people will perhaps not be very interested in, a developer team who says, I want to do we want to build something on containers now. We want to adopt a microservices oriented architecture. We want to do this, we want to do that, and operations people are going to go, okay, why should we be involved? Well, because it's their business in the longer run. They'll have to support that new thing. So I put some logos there of these different tools. I very much like incident problem management, because it gives you a view on what works and what doesn't work in your organization. You can do root cause analysis on them, improving incident and problem management using tools like ServiceNow. Or for me, I very much like ServiceNow. For me is a bit simpler, but it works fine. You'll also, from an operations side, will use tools sort of indeed to monitor, to see what happens, so that you will have monitoring tools like Grafana, which is more like a dashboarding tool with tools below it. Prometheus, Victoria Metrics, Ichinga. You will have your virtualization architecture. It can be on VMware or Citrix load balancers for the front end, and or in various combinations. You will have, of course, your stacks. I will talk about that. Your application stacks that you have to manage, which may be, a .NET stack or an Oracle stack. I will talk more in detail on that. But you can see it's clearly a different business than these what I put there. Integrated development environments of the development environments that are not so well integrated. You will have the whole Google Go ecosystem, for example, which I like very, very much. I will talk about it a little bit later also. Open source repositories, GitHub, from which you can download, use open source frameworks. You will have Visual Studio is a very well integrated development environment for everything that is near or far from the Microsoft .NET stack. So microservices becoming very powerful as a new platform, Docker, with Kubernetes clusters. So the two are linked by a number of key functions and processes that link indeed operations with development teams. You need to manage the deployment by line. So you create and you software artifact. So how is that going to come on stream? Related to that, the second thing, sort of, you need to keep track of versions, version control. You need the release management. Release management involves, quality checks to really verify and validate a new release before you put it on your data center or in the cloud. You need to manage your environment. I said very functionally, test environments, integration test or business acceptance test, and then finally you go to production. All these environments need to be managed, and that's often done by the operations department rather than the development teams. Configuration management, maybe environment. You can also look at from a technology angle. You will have various configurations to manage. The software components of that need to be updated. You'll have tools. That's a tool I didn't put on there, but like Puppet, sort of. We need to update from RHEL 7 to 8. And incident problem management, indeed. When you put something on stream or you change something, help desk functions. Your help desk needs to be aware. You need to anticipate incident and problems to make sure that they are resolved quickly. I like that sense here. Incident response is one of the most important aspects of running a Kubernetes deployment. A well-defined incident response plan can help you quickly identify and mitigate issues with your Kubernetes deployment. And that's from a guy I like very much, who says a lot of sensible stuff about this new services architecture. I talked already too long on what I presented in a previous presentation and previous video. So let me go to what I do want to talk about is yeah, the management of application or systems architectures. And I'm doing this presentation is going to be quite technical, and I'm going to present the conclusion first. Um, I said managers, I think they can no longer afford to sort of say, well, that's technology that I'm not aware of, and I'm not a programmer, and what is this Kafka and middleware, and I think you need to understand the basics, and that's the purpose of this video here, is to sort of present a few concepts, talk about how technology has evolved over the past 30 years, and sort of what I think the main thinking should be in regard to these things is. I often get asked, "What do you think about this? What do you think about that?" Well, I think we should think fit for purpose. To explain that, I'll go a little bit through the historical evolution and of software stacks on systems structures, and how they actually yeah, evolved over the last. So to do that, I made a sort of I jotted a lot of things down on the whiteboard. I'm gonna make that a bit bigger, and so I'm just gonna walk over that. I think it's a bit of a cliche, but yeah, I grew up. I got into the business as an Accenture consultant in 1991. That was sort of the end of, I would call, yeah, what is now referred to as monolithic programming. Really sort of the concepts that you would associate with mainframes and dumb terminals, where we had one program, a COBOL program, something very large, something very structured that did online processing with embedded SQL on what were then already relational databases. And then a lot of batch jobs that you also had to program that ran overnight. And I think mastering that stuff, database technologies, and then a procedural language like COBOL, and then sort of knowing how to do batch jobs. Well, you were pretty much set as a technologist. So then. We know what happened. The World Wide Web came into existence. It's nice to remember those days. This British Berners-Lee, who worked at CERN, then invented the hypertext. And he also implemented the first web browser and server based on the hypertext transfer protocol. It's funny to see that CERN network at the time was used by a lot of people. It ran on at that time by what was Steve Jobs' very first company, Next. He had built a workstation with pretty advanced components, which were then later used in the Macintosh Quadra. Yeah, I put some things here that remind me and make me a bit melancholic about these old 32-bit chipsets and what they worked with. But all the basics were there, Ethernet ports, pretty powerful. I mean, at that time was one plus gigabyte. We're talking terabytes now. You need to add a thousand factor to everything, but hard disk drives. But it kind of worked. What we had basically were typical stacks. We would put logic on the client side, which could validate data in a form which could already, implement certain business rules on the client side. So we would offload that part of the logic and CPU time to the clone. So these would communicate with a web browser. Today we have applications, but it's basically the same thing through an HTTP protocol. The web browser with a web server. All right, this is an open standard, yeah, Apache service, and then that would make a call to some logic, to an executable program. Put here written in Perl, PHP, or Python, because this is an open source stack that I'm presenting here. But it could be a Java program, or and that would do database queries. Again, here we're talking an open source stack, a bit as a reaction to what I could present here, the Oracle stack. But I don't do that. So yeah. I worked on Linux. We had that separation between Windows clients and operating systems that ran on servers would often run on Linux, which for some reason was also considered to be secure. We had the thing with this was we would have, of course, many clients and only a limited number of servers. So to entertain many users, you need to organize threads, or even at that time, servers are more powerful now. But this was basically the thing. That so how do you handle many user requests on with limited computing time and CPU time was one of the reasons why you actually wanted the client server in the first place, so that you could have a client that can execute and offload tasks from what used to be your mainframe is now a server. So that's what happened. All this stuff. Maybe I can briefly present the Oracle stack here. The difference is that the application server would be a proprietary server, database as well, WebLogic server, and then you would have a WebLogic compatible proxy server, which could be basically any server. The operating system would be proprietary at the time. Solaris. That has also changed, or became a mixed stack. So the logic basically there is that a web user would submit a form. Usually, I mean, in the early days, we talked about web forms. That was easy for programmers also. Everybody understands forms, to automate forms. So we would have basically forms dancing on a database, but through, an HTTP web server. So user would submit a form that launches then an HTTP request with the URL, form data, and then some script. A script here, CGI script, common interface specification script. That's not necessarily written in a scripting language, but it would execute some program logic while passing the data to it. The output of the script would be returned to the web server, and the user would be informed that his request has been processed. I said there were a lot of standards development there quite early on. 1997, I think we had the Common Gateway Interface Standard specification, based on which we have what we have now. And that's a lot of similarity and interoperability between various systems, and especially in the area of HTTP server packages, Apache, Microsoft Internet Interface Services, Information Services, or Node.js, etc. I said I think the standard example of that is really in terms of what were the technical implications, processing of forms, I would say. We know how it works now. Have an action attribute in the HTML form, a submit button, and on click. So these were the predecessors to what we have now, which is a lot more what is referred to as user generated events, and I'm going to talk about this in a while. So query strings, we know how that works, parameters that get passed, all that kind of stuff. This goes into the technicalities of how this happens. I'm not going to go into there. So the basic thing to remember is that the program logic, you indeed go from monolithic programming to a model where your program logic is indeed distributed over various computers. The thing that let's say this should have led to things that become a lot easier. Now, why is it still so difficult to deploy, new applications? Why does it take so much time? Well, to this distribution of logic, I would say we must remember that there's still a lot of things that are really platform specific or development environment specific. Java application service are not the same as .NET service, PHP application service. And the second thing I would say that has added a lot of complication in terms of how you manage your system is with systems that have thousands or even millions of users. I'm thinking of think of an online game which will have about 1 million simultaneous users. The model that you have here is pretty much sort of synchronization or continuous processing of requests. We assume that indeed the data center, our data center will have enough capacity to handle all these requests on time and real time. And this is something that very early on, I think people manage. Maybe it's better to sort of organize a queue and think of what is called asynchronous communication between processes or execution threads, if you want it. And that's a difference between the synchronous model that I presented, or sort of a request response oriented architecture. Often that's referred to as a restful architecture for representational state transfer. But it's a bit more than that. To illustrate the principle, I would say okay, we have messages, events. What's the difference between the two? I should have an example here. This is not sort of a really high level, but this would be an example of a message. We have a message that basically says some user wants to do a bank transfer. And the data that comes with it is a transaction ID, of course, the account from which the money has to move, with the number of the account to which the money has to move, the amount, and the currency. So that's sort of a message that sits somewhere in the system and waits to be executed, to be picked up by an application. So that would be a typical example where a producer, a bank customer, would produce a message, and now we would have consumers, the applications that pull a message like that off the queue, process it, and remove it. And the nice thing about the example is probably that we would have an event, and we can also look at an event as a sort of a message which says, okay, fine, we've done the bank transfer. The bank transfer is done, and so we can now inform the customer, or the customer should be informed that the bank transfer has happened. There's a timestamp there and other event data, the original transaction ID, the two accounts, the amount, etc. So these are events and messages, and so these need to be managed in a system. That's where all these middleware comes in. I could give other examples. A button click in a UI. Think of a website where a user is looking up an address of a bank office and wants a map with it. So then we need to call a map from another application. A motion sensor recording movement. A system needs to be alerted, but there's a lot of events taking place. So that's where you would have this sort of second type, but I said they're closely related, where we talk about events and event brokers rather than message queues. The two concepts are often used a bit interlinked in. There's supporting technology examples, RabbitMQ, I mentioned open source one, Apache Kafka. Interesting about Apache Kafka is that it was actually originally developed at LinkedIn before it was acquired by Microsoft. Microsoft, of course, and other vendors have their own proprietary messaging, queuing, and brokering software, Microsoft MQ. That's no longer supported under Windows 11. It's now part of other of sort of the larger SQL Server integration services facility and package. But that's basically what this middleware is all about, and why things indeed have not become very simple. We need to work with a lot of different softwares, and I will conclude this presentation. I won't make it too long with sort of talking a bit about that. One of the questions you'll forget is, oh, well, do you like Java? Well, yes, I know. Do you like Go? Yeah, I like that very much. Why? Well, I'm an older man. I've got like 30 years of experience. I would go back to sort of, languages. I said your systems architecture need to be fit for purpose, and I would say the same thing about programming languages. You need to be able to work with many. Often, and I'm going to take the very blunt and stupid example of COBOL code. At the end of the 80s already, developers came up with this idea, like, we want to program in a high level language, and that led to C, where indeed you have this example. Which Brian Kerrigan wrote down at the time, like, a program like this. We define main, a package or a module or an executable file, and then, between brackets we have a function, printf, and then we specify what we want to print, and that should do the thing. Yes, simple, especially if you compare it with what the same thing would be in COBOL here. But this is sort of how COBOL, a job in COBOL that would do the same would be written in, well, around the same time, 1978. You see, this looks very complicated. To me, it doesn't. It just, it goes under the hood. You need to specify on which environment you are working, what the source computer is, what the object computer is. There's a data division. You need to declare explicitly a lot of stuff. And the thing is that this looks more complicated, but at the same time, I will defend it. If you really would want to execute this program in C or in C++, well, the programmer would also sort of need to refer to. He would need to write it like this: a statement that says, okay, which library am I going to use? Because the printf function needs to be specified somewhere. The logic of that function, how it executes, it needs to be somewhere, and so that's in the library then of C, the standard io.h. So we would include that package, and then we can write our program. Now, to name our program, or as a package, we would name it main indeed, but we would write it something like, we declare this program main to be like a function or a package or whatever, which has no input arguments. We're just going to run it, so that's why we call it void. And we want to know if the program got executed or not. So many programs would indeed return some exit value, and that's why it's an integer. So as you can see, there's a lot behind under the hood. I would say under the hood, there's engines running, and so you have a sort of a false sense as a programmer of well, I don't need to specify that, I don't need to be worried about that, but you do. I'm not going to go into the detail. Maybe just show this. I have a few development environments on my laptop. I could probably run it here. Show it here, yeah. So COBOL looks a lot simpler now. There have been revisions of it. This is an example of an open COBOL implementation by GNU. For me, it looks as simple as that C program, Hello World program. Yeah, an identification division with a program ID. You need to name it. Data division is empty. The file section is empty. Working storage section is empty. Now we have the procedure division, which says the main procedure is, well, display hello world and the program. Easy. And as you can see here, the program underneath, it does finish with an exit code 0. So that's what I said when you need to, why sort of you will have this code int main void, which for me is not very readable. This is much more readable than C code. Or let me go back to another example. God, it's slow and loading my whiteboard. Yeah, for tectonics. I wonder what is this for a header? Author, data purpose, and tectonics, but apparently that's just a nerd slang from one of the founders of GNU for describing the code building process. Just maybe that to sort of give you an idea or what is under the hood of that. You know, it's a lot. Huh? There's a preprocessor which indeed does that interpretation of the first utilities or packages you're going to use. Then it actually translates COBOL to C, which that's GNU. It brings everything to C, and then it compiles it into assembly language. But the linking, the building, the job running that runs underneath, it's there. And as a programmer, to make things work, you need to be able to get under the hood. This is another thing where, talking COBOL, and I really like this from the GNU COBOL IDE that I downloaded, and when I read this introduction to it, yeah, COBOL verbose, but I like this comparison between it's important that code is readable, and indeed it's sort of you don't think of it when you work in the Java world and when you're a young developer, but look at this indeed class. Hello world is the hello world program, and then we have this public static void main string args, and that's like main void, but we declare a number of properties of the class from where we can access them in the system. This all makes sense, but it doesn't make sense for an outsider when you compare it to COBOL 2002, where we say, okay, we identify the program through a program ID, and then we have a procedure division, and then display hello world. I mean, you tell me which program is more readable. I would say the COBOL program, right? And but COBOL is wordy. Well, count the words in the two programs. So I really like this comparison. Hello world doesn't look any better in Java than it does in COBOL. And but COBOL is not object oriented. I haven't been following up, but look at what COBOL, this is from Wikipedia, what COBOL can do now. The browser is not working apparently. The COBOL 2023 standard, apparently, and already from 2014, COBOL became more object-oriented, but it can also do, this what I talked about, asynchronous messaging logic in your environment. And it can do a lot of other stuff. So COBOL has gradually acquired, and I think it might. I mean, it's never going to be a popular programming language, but we can't do without it. A telling statistic is that everybody tries to get away from their legacy systems. According to TechTarget, about 75% of projects that aim at really eliminating COBOL from in your ICT organization fail because they're costly, they're expensive, and it's not that easy. And that's where maybe I want to go back to this presentation here. Don't look negatively at your legacy. This is sort of you see it have here a portfolio, a very simple portfolio a classification example where I say like, okay, you have projects that relate to your legacy, and then you have projects that relate to new developments. I'm always saying like, if you don't watch out, your legacy of tomorrow is what you're developing right now, and your legacy, it's there. Look a bit positively on it and look at how you can improve it, and make sure that you invest enough in bringing your legacy up to the latest security standards by indeed investing in the right technology platforms, upgrading them. It's often cheaper than starting something from scratch. So I think I will end with that. I'll just quickly see if there's anything else. My computer is kind of slow today. That I wanted to say, probably not. No. Just a conclusion again. When you think about these things, investing in new technology or systems or upgrading or whatever technology project, think fit for purpose. Think about it, how it fits in. Start from where you are, and make sure it's fit for purpose. If the introduction of microservices is being sold to you by your CIO or teams as well, this is going to hugely increase performance. Ask the tough questions. How exactly? Usually, if you're gonna go for like totally new application architecture using containers, microservices, a totally different way of managing applications, you will need to refactor them. You are rewriting them, and that rewriting should go beyond repackaging them. I can mention the example of an organization I worked in where well, we're gonna move to containers. So what they did basically is they sent the source codes of their PHP and Java applications offshore, and it came back as containers that they could run on Docker and in the Kubernetes cluster. I've never seen any evidence of, and they didn't bother to measure it anyway, sort of a baseline where we said, okay, this is the performance of our systems now. And when we're going to repackage or refactor, they didn't refactor actually a lot. But when these things are going to run on containers, then we think we're going to have a 20% improvement in performance. We're going to need, less virtual servers or real servers. We're going to be able to sort of scale down hardware assets. Our data center won't need that many physical servers, blah blah blah, and this and that. No, I didn't see it happen. And so you wonder, like, okay, this was a lot of investment, a lot of money, and that's maybe something I want to still highlight here, is there was a lot of money, and you wonder, like, what was the big deal? This is something, a discussion I saw on I think it was Tech Stack, where a guy apparently pretty high up in the in ICT organization asked like, okay, I want to do an event-driven architecture. So what should I use, Kafka or another solution? And this is an answer that I liked very much from a software architect at a company. I don't know. Something is missing in your question. You should consider answering that. You are building a couple of services only. Yeah, that what came out of the measure. So why would you be considering event sourcing architecture using message brokers such as the ones you mentioned? Wouldn't a simple REST service based architecture be sufficient? So read a little bit about event-driven architectures and the various modus operandi that come with it. Publishing subscriber model or push-pull. Do you need querying? How are you going to organize it? And think about the structure you will need to have to put in place to manage these brokers, unless you use, of course, a totally managed cloud provider based solution. But you know how it goes. Nothing is completely managed. So yeah, you need to automate the deployment. Somebody would need to take care of backups. This is clustering if you're talking about performance. Disaster recovery, etc., etc. And so I like what he puts there. I'm gonna maybe highlight it. In my taste, you should go with a minimalistic approach and try to avoid either of them if you can. So if you can avoid sort of this middleware, if it's not really necessary, I don't know, Kafka and um, or an accent framework, yeah, avoid it, especially if your architecture doesn't fall nicely into sort of something that is driven by events. Yeah? You might have applications that are entirely data driven. And then if not, of course, he says I would examine Kafka because it is able to work with multiple stacks, etc. But this is a nice way of thinking. Take a step back, think fit for purpose, and just don't rush. Technology is a solution to many problems, but you need to think about which technology and sometimes it's better organization, better management, better architecture, rather than just pumping in more or new technologies or platforms. I'm gonna leave it at that. I don't think this was a great lecture. I said it was a bit of rambling and more of a preparation for something that might be more structured in the future. Any case, if you listen to this, thanks a lot, and do not hesitate to provide feedback. Thank you.